All right, this is 4.2, solving linear inequalities. So I mentioned a bit earlier, there's not much to this lesson. Rather than using an equal sign, we use a less than or greater than sign. Okay, so our goal is to solve linear inequalities. So in mathematics, you must be able to represent intervals and identify smaller sections of a relation or a set of numbers. You've used the following inequality symbols. So these should all be reviewed. Everyone should be familiar with these, right? Greater than or equal to, less than or less than and equal to. Okay? So what we're doing now, if we have an equation that looks like this, 3x minus 1 is less than 8. We want to solve this. Okay? There's going to be, of course, one answer because there's a lot of answers that can be less than 8. So instead of one answer, we're going to have multiple types of answers. So for our purpose, we can treat it initially just like an equal sign, and all the reverse operations that we would do with an equal sign here, we would do the same thing. Okay, so if we have 3x minus 1 is less than 8, we can move this negative 1 to the other side. So we have 3x is less than 9 because it comes positive 1, x is less than 3. Okay, so nothing changes. Okay, we just kind of treat it like an equal sign. The only difference is with certain operations, we're going to have to change the direction of this inequality. Does anybody know what that is already? You guys, I think you've learned this already. Anybody remember? Nobody remembers the operation that creates this inequality, flip directions? Okay, we're going to see it in 1 minute. So just to get a definition out of the way, in linear inequality, it's an inequality that contains an algebraic expression of degree 1. Okay, so all that means is that the greatest exponent of the expression is 1. That's what makes it linear. Right? mx plus b, that's the equation of a line, so it's a linear inequality. This number line, we should be familiar with how to create it. Okay, we end up with, this is a representation of x is less than 3, this number line here. So we have an open circle around the 3, and then we have a solid line moving less than 3. Okay, any questions about this number line and how that number line is a representation of this inequality? No? Okay. If I had a solid line here, if I had x is less than and equal to 3, then this dot up here would be a solid. Okay? Okay? The way we represent that in set notation is two ways. One, we can write it like this or like this. Okay? Both you should understand. Okay? X is a set of all real numbers where x is less than 3. It's pretty much identical to just what we're trying to represent. And the other one is xe with open bracket negative infinity up to 3. Remember, these are both values of x now. This is not a y and an x and y coordinate. This is a negative infinity value of x going up to the value of 3. We use open brackets when we don't include that number. And then we use square brackets when equal. Yeah, I'm going to move it up. When equal. Okay? When equal or include that number. I'll show you an example of that in a minute. Okay? But open brackets means that it's doesn't have the equality. It's just less than. Okay, that's why it's open brackets. And you can't include negative infinity since it's not a number. Yeah.
So would it be like the open circle would be with the open bracket?
The open circle? What open circle? Yes, yes. Open circle here goes with these brackets. Closed circle goes with these brackets. Yes, good. Okay. Question?
If one's open and one closed, do you combine them?
Yeah, you can have if one's open. So say you had an equality like this. X is less than 8, but greater than and equal to 3. This would be like this. Okay? Okay. All right. Okay, so very quickly here, solve the inequality. This is the one we just solved. I solved it on the other page. X is less than 3. We have our bracket. We're checking the left-hand side by plugging in a value that's less than 3 and then making sure that it's less than the right-hand side. So that's fine, that works out. Two, can you add, subtract, multiply, or divide both sides of an inequality by a non-zero value and still have a valid inequality? So here's the question of the day, the question of the lesson. Can I make all of these reverse operations and still have the equation hold true? Okay, so here we're going to try each one. I add 5 to both sides. 9 is still less than 13. So this guy works. I subtract 5 from both sides. Yep, still works. So subtraction and addition work. This is still subtraction and addition. All right, here's multiplication now. The result is still true. 4 times 6 and 8 times 6, 24 is still less than 48. So multiplication, addition, subtraction, all okay. Sorry, I should put in, oh, you're gonna see in a second. Okay, we run into trouble when we try to multiply by a negative number. Okay, that's where things get strange. So we had 4 is less than 8. If I multiply both sides by -2, my inequality becomes -8 is less than -16. We know that's not true. Okay, so this doesn't work. Okay. If we divide by a positive number, it still works, so it's okay. But then the same problem occurs if we divide by a negative number now. If we divide by a negative number, it's no longer true. Okay? So these two scenarios, this one and this one, is the only difference between equalities and inequalities. Yes? Yes. So what we need to do then is just, if we're going to divide or multiply by a negative number, we have to reverse the sign. Okay? So notice how, in this case, -8 is greater than -16, so we reverse it. So let's see that example here now, example 3. Okay, so we have this equation here, 35 minus 2x is greater than and equal to 20. So here we subtract 35 from both sides. So we get -2x is greater than and equal to -15. Now even though we're dividing here by -2, this inequality switches. So it switches side, the direction it's going. Okay? It flips from there to there. Okay, that's the whole lesson really. If you divide or you multiply by a negative value, you flip signs. Okay? Obviously, if we're going to be flipping signs, you want to save your divisions by negative numbers till the end. Okay? You want to try and do all the other operations, and then at the very end, if you need to divide by negative or multiply by a negative, you do so at the end and you flip it once. Okay? You don't want to start dividing at the beginning and then having to flip multiple times. Okay? Here's the number line that represents x is less than and equal to 7.5. Notice the solid dot now because of the equal sign here. Okay? Yeah.
So, will we need to draw a number line?
Yes. You have a problem understanding this?
No?
No? Okay. So here's just a check up here. We're just checking, and then of course we realize that by flipping the inequality we get the right answer. Okay? Another way to write that solution set, x is less than and equal to 7.5, is in set notation. Need to know both of these. XER, x is less than and equal to 7.5, and the interval notation XE, open bracket negative infinity, because we cannot include negative infinity. It's not a number, so that's always open on the infinity side. And then close bracket on the 7.5. Okay?
So sir, if it's an infinity side, you always put...
Yes, always open. Okay? Example 4. Almost done here. So here we have a big long inequality. Notice there's two inequality signs. Okay? This is maybe the one scenario that might trip you guys up. The only thing that you need to be aware of, if you're working within those inequality signs, so if I'm just working with here, I can expand and simplify. So see, I've done that. I've expanded that 3x plus 4. I don't need to do anything, just expand and simplify until I'm at this point. Okay, haven't changed the 30, haven't changed the 46. All I did was expand and simplify the middle. Now, I want to have the variable in the middle. Okay, if there's any variables on the either side, you have to bring them into the middle. Okay? Whatever you do with one inequality, you have to do with the other. Okay, you can't just put minus 10 on one side. So because I want to get rid of this minus 10, I have to put it on all three sides of the inequalities. So I put 30 minus 10 in the middle, and 46 minus 10. So that's the only trick. You need to do it on all three. Okay? So that leaves me with 20 is less than and equal to 4x, which is less than and equal to 36. Any questions up till here? Okay. I divide by 4. And I'm left with my answer, which is x is greater than and equal to 5 and less than and equal to 9. And there's my number line. Set notation, there's interval notation. Set notation would be XER, where x is greater than and equal to 5, less than and equal to 9. Okay? This is called set notation. This is interval notation. So, in summary, you can solve a linear inequality using inverse operations in much the same way you solve linear equations. Okay? If you multiply or divide an inequality by a negative number, you must reverse the inequality sign. Okay? If you have a double equality like this, and you were to multiply by -4 or divide by -4, they both would change directions. Okay, not just one, because you're dividing both of them by -4. So they would both switch directions. Both of these would move in opposite directions. Most linear equations have only one solution, whereas linear inequalities have many solutions. That's because there's, an infinite number of values less than 8, for instance, but there's only one equal to 8. A number line can help you visualize the solution set to an inequality. A solid dot is used to indicate that the number is included, whereas an open dot, the number is excluded. Any questions?